Welcome class, this is your Catia mentor and today we're going to talk about curvature continuity. We're not going to get into mathematics of curvature continuity. We're going to learn how to apply it to surfaces. So whether you're creating furniture, making seats, you want some nice clean surfaces to transition from one surface to another. You want shapes to be ergonomic, maybe even futuristic as you're creating these surfaces. You're trying to avoid using straight lines or flat surfaces or even cylindrical surfaces. And the reason is it just looks a lot cleaner when you avoid using circular surfaces. You want to use other conic shapes other than circular. Here we have a surface, compound surface changes direction on this outdoor radio. So those that are very creative, those that like to draw, have that creative gene, they understand curvature, whether it's on edges or surfaces. They're very creative, and these creative designers are the type of people you find in studio departments. So if you ever get to work in an automotive company, or you want to work for an automotive company and you have that creative gene, you may want to work for a studio department where they come up with the concept cars. So in automotive, when you're looking at a surface, the exterior surface that the potential buyer sees when they go to the dealership, when they're looking to buy a car. Also the interior surfaces, the seats, center console, dash, they're referred to as Class A surfaces, even the rims. So those are the exterior surfaces and interior surfaces that the customer sees. There's some surfaces you cannot see, they're referred to as Class B or Class C. Obviously manufacturing engineers that design the vehicle, they'll see those surfaces as they're designing the vehicle. So in automotive, you're going to see stylists. So the ones that you see here carving from the clay to create this new concept car. They have the creative gene. They also draw a lot of pictures on the wall to show off their sketches. So you see sketches all along the walls that are pinned up to use for inspiration, to show their creativity, and then apply it to the clay models. So from there, once the clay model is done, they'll digitize the surface of the clay. They'll have a setup, almost looks like a homemade car wash, and it has an arm that'll go over the top and scan the surface of the clay model. It'll save it as a file, and then they turn that file over to the digital stylist. So they're the ones behind the computer. They can be on the first floor, second floor. They're the ones that take those digitized surfaces or point clouds of the clay model and turn them into manufacturable surfaces. So we need to recreate these surfaces if you're a digital stylist. And the reason is you have to recreate them is because since it's clay, there's going to be some small imperfections or even holes. So you need to recreate the surface to then model the part and also create clean surfaces for manufacturing to make the part. Alright, so when I use the letter C, I'm referring to curves. When I use G, I'm referring to surfaces. So the first type of continuity we're going to look at is C0 point continuity. But before I get into the slides, let's go ahead and model something up real quick. So most studio departments, they'll use a software like Catia or Alias or another advanced surfacing software to create their surfaces. Okay, I'm going to start by inserting a geometric set into my Catia tree. So typically in a geometric set, this is where you want to keep your points, lines, planes, surfaces. Solids, you want to place them in the part body. So when you're creating a pad, extrude of a solid, and later you want to create a hole or a pocket, you do it in part body when it refers to solids. And everything else you put in a geometric set, non-solids, points, lines, curves, planes, surfaces. All right, so geoset is underlined, so anything new I create is going to go into the geoset. If it's not underlined, just right-click Define. It'll underline it, and anything new you create will go into that geoset. Just think of your Catia tree as a school binder where you have one division for your math, another division for your chemistry class, etc. So try and stay organized when you create your models. All right, so let's go ahead and create a spline. Instead of creating the spline in 3D, I'm going to just create it in Sketcher. So I'm going to sketch on this plane. And I'm going to create a simple spline. Okay, I'm going to go ahead and exit. Click on space to deselect. And you can see that I have my sketch of the spline in the geoset. I'm going to go ahead and give this color. So I'm going to right click on Sketch 1, Properties, Graphic tab. The first one is to give surfaces colors. Second one is for the edges of surfaces or the edges of a solid. And this one is to give curves and planes color. I'll just make it a dark blue. This one will give you line types, dashes, phantom lines, dashed lines, continuous lines. I'll leave that alone. And I'm going to go from a thickness of 1 to a thickness of 5, which is 1.4 millimeter line thickness. And hit OK. Click in space to deselect, and I have my blue line. All right, I'll create a second sketch. I can just go straight to the same plane. And since it's intuitive, I can pick from these options here. I'll create a sketch. Okay, so I'm going to go ahead and create a sketch. And I'll create another spline. I'll just make it a lot simpler. Exit spline and exit sketch. Okay, so currently there's a gap, so there is no continuity between the blue curve and the second curve. So we don't even have point continuity here. There's a gap, there's a break. So let me first change the color of the spline, then I'll go back to the notes. I'm going to give this a color of green and a thickness of 5, which is 1.4 millimeters. Okay, so we have our two curves. Okay, before I go to the lecture notes, here we have a nice clean spline, so it's curvature continuous. Then we have this second curve. It's also curvature continuous throughout. But then we want to connect them. Right now there's a gap between them, so right now there is no continuity. There's a break. So let's first accomplish C0, which is referred to as point continuity. C for curves, G for surfaces. So currently we have two curves and we want to connect them. So this is referred to as C0 point continuity. So let's go ahead and connect the curves. Go back to Catia. So I'm going to go back into Sketch 2. And I'm going to connect the two curves. There it is. I'm going to exit. So now I have C0 point continuity. Okay, so we have a nice smooth curve that all of a sudden has to make a sharp right turn to connect to the next one, right? So let me look at it from the front view. So before I go back to the lecture notes, let's talk about curvature continuity and why it's important. So imagine you're riding along a road, or you're on a train, railroad tracks, or you're on a roller coaster. Imagine going at a high rate of speed and all of a sudden you encounter this second curve. Obviously the train or passengers are going to fly off the rails, right? If you're going on the road, going at a high rate of speed, and all of a sudden you encounter an intersection like this, you're not going to make that right turn. So you're going to go flying off the road. So when you think of curvature continuity, think of a nice beautiful road, railroad tracks, or roller coaster tracks. Okay, so we made a connection. So if you were riding along this road, you would have to basically stop, look both ways, make a right turn, and speed up. Okay, so let's say we wanted to go fast at this corner without having to slow down or stop. One thing you can do is smooth out the transition as you go from the blue curve to the green curve. Okay, so we're going to take it to the next level. So we already have C0 point continuity. So now we want to increase it to C1 tangent continuity. Okay, so let's have a quick review on tangency in case you forgot what is tangency. So I'm going to create a third sketch. I'll just draw a circle. Notice the two lines slide up, telling me I have tangency. Okay, so tangency, here's a good example, is when you have a circle or an arc and a curve or a line. In this case, it can be two curves, it can be two circles. They only intersect at one point. Not at 2 points, and we have tangency, right? So one good example is if you're going down the road, you're getting on an on-ramp to get on the highway, right? And it may curve, and then you're on the main road. Or as you're exiting a highway. Okay, same idea. Okay, so we're going to accomplish tangency on the next step between the two curves while maintaining point continuity. Okay, so we have point continuity, C0. Now we're going to improve on it by adding tangency. Okay, let me exit this sketch. Alright, so what I'm going to do is I'm going to actually introduce a third curve to connect them. Typically that's what you end up doing when you're combining two curves or two surfaces. So what I'm actually going to do is turn these into surfaces, then connect them with the third surface. We could do it with the curves, but I want to introduce surfaces also. Okay, so I'm going to turn these curves into separate surfaces. So I'll take the blue one. And I am in generative wireframe and surface app or workbench or module. This is the current app I'm working in. Alright, so let's go ahead and create an extrude. So I'm going to go to Essentials, create an extrude off of the blue spline. And I'm going to go up to 100 millimeters. In both directions. And OK. I'm going to go ahead and change the color. Right click Extrude, Properties. And again, the first one is to change the color of a surface or a solid. I'll make it blue and OK. And I'm going to also extrude the second curve. I'll keep it at 100. And I'll turn it to a green color. Right click Properties, Graphic tab, Fill Color. I'll make it, I'm going to go to a lighter green. Okay, so there we have our two surfaces. Okay, so as we go from one surface to another, this has nice curvature continuity, but as soon as that gets to this intersection, this transition, it drops down to G0 point continuity. On the two curves, we have C0 point continuity. All right, so now we're going to improve on this, and we're going to introduce a third surface. Let me actually change the lighting. Let me go to View tab. I'm going to change the lighting. One light source, two light sources. Okay. We can actually increase the intensity if we want. And I'm going to close. I'll come back to this, to the lighting. Okay, so just like the sketch on the circle, so we have the line perpendicular to the curve, where we go from the extremum vertical point, or I should say the top quadrant point on the circle, to the center, right? And they both come off at 90-degree angles. So there we have tangency. So we're trying to accomplish tangency just like the line to the circle, intersecting at one point, point continuity, and it's also tangents. So it's C0 and C1. Okay, I'll exit this sketch. Okay, so I'm going to introduce a third surface to transition from the blue to the green, make it a smoother transition. So a good example is getting a tailor-made suit or a wedding dress, for example. Let's say this is the sleeve. So first you'll create the sleeves, and then you'll sew it up to the shoulder area of the suit or the wedding dress, and you want a nice clean transition. Or it can be, let's say, the bumper of a car that's transitioning over to the trunk of the car, right? You want a nice smooth transition. Or it can be the fender of the car, where you have the wheel well area transitioning to the hood area, for example. Okay, so in most cases you do want a nice smooth transition. Sometimes you do want that sharp transition. But in most cases, you want a nice, smooth, clean transition. Okay, so let's improve on that. And what we're going to do is we're going to bring in a fillet. So let's go to Essentials. We're going to bring in a shape fillet. And we're going to go from blue surface to green surface. Okay, notice these white arrows. There's actually 4 options or 4 ways it can create a fillet. It can create a fillet here. What Catia sees, it sees a green surface that overextends. Same thing with the blue surface that overextends, creating 1, 2, 3, 4 quadrants. So Catia does enough to make the fillet here, 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 or here. Okay, so you need to tell it, and you tell it by pointing the arrowheads towards the center of where you want the center of the arc. So, or pointing towards the quadrant where you want the center of the arc to fall in. So we want the arc here, so the center point, we want it in this quadrant, right? So we need to point the arrows inward to say we want the center point in this quadrant and not this quadrant or that quadrant or this one. Okay, so I'm going to go with the 50 millimeter radius and OK. And it's combined it into one surface made up of 3 patches. So again, think of this is the sleeve, this is the shoulder, and this goes up to the collar of the suit or the wedding dress, for example. So we made an improvement on the transition. This is something you see on the highway, right? You're going from one highway and then you're going onto a different highway and you have a transition, right? You transition over from one highway, you want to get off of the blue highway, transition over to the green highway. So think of, again, driving on a road or riding a roller coaster. So you just made an improvement on that transition. Okay, so in this case, I didn't introduce in this slide a third surface, but just to get the point across, we have tangency, and we still have point continuity. So we have C0 and C1. But for us, we have 2 tangent lines or transitions because we introduced a third surface. So let's go back to the 3D model. So we actually have this transition and this transition. Okay, so this surface has curvature continuity, right? It's nice and smooth. You don't feel the bumps on the road. It's a smooth ride, and all of a sudden you encounter a fillet, right? Where there's tangency and point continuity. So you'll feel the change as you're going from one road, transitioning to the next road. So you will feel the difference. You feel the centrifugal force trying to pull you out of the car as you're making the turn, right? Okay, so even though we improved on it, we can still do a lot better. And again, we have 3 surfaces and 2 transitions. The transitions, we have C0. In this case, it's surfaces, so I should be saying G0 and G1 continuity. Point continuity and tangent continuity. Okay. Okay, so in our case, we have 2 points, right? And this is where or actually, let's put it over here. We would have a point here and a point there where we have C1 and C0. We would have the third surface here. Okay, so now we can improve on that by making the radii equal to each other as you go from one surface to another or one curve to another. Okay, so in C2 referred to as curvature continuity, G2 if it's surfaces. So to improve on that transition, not only do we have C0, point continuity, C1, tangent continuity, now we have C2. The radii are equal. So the radius as you exit equals the radius as you enter the next curve. So imagine you're driving along. Imagine you're going at a high rate of speed. Let's say you're going 100 miles per hour. And you start slowing down to 90, 80, 70, 60 miles per hour. Okay, so your velocity as you're exiting is 60 miles per hour. And as you enter the next curve, it's also 60 miles per hour. So that gives us an equal radius, right? If the radius here is 100 and the radius is getting smaller, 90, 80, 70, 60. Let's say we drop down to a radius of 60 millimeters. The radius here is also 60 as you enter the next curve, right? So that gives us C2. All right, so we're improving on the quality of the surface as you transition from one to the other. Okay, so what I'm going to do is I'm actually going to hide this fillet. I'm going to introduce another command that maybe you are familiar with or maybe not. So I'm going to go back and show my original two surfaces. Okay, so one of the little tricks that you will learn if you work for a studio department, for example, in automotive, where you're recreating the surfaces that the clay modelers, the stylists created, and it's your job to recreate the surface in Catia or Alias or another software. One little trick is to create a cylinder. Okay, so I'm going to create a cylindrical surface. So let's go to Surface, and I'm going to go to Extrude and Cylinder. Okay, so I'm going to create a cylinder. I'll use this point here. It's my starting point. And in my case, I'm going to go in the X direction. I'm going to go this direction, X direction. So I'm going to right click in here, go to X direction. So there's the axis. And I can use the arrows to stretch it. It's okay if I extend this cylindrical surface. Okay, so I'm going to make the radius, I'll make it 50. And okay, see what we get. And I'm going to come back and turn on that fillet. I'm going to come back and turn on that fillet. I'm going to make that fillet, give it a color, right click properties. I'll give it a tan color. Okay, so this is the fillet we created earlier. And once again, when it transitions from the fillet to the blue surface, we have a tangency. So we have a tangency line here, and we also have one here. So once again, because it's surfaces, we have G0, point continuity, and G1, tangent continuity. So we're trying to improve on that. And by the way, if you ever worked in a studio department, they'll refer to arcs or cylindrical surfaces as boring or ugly, right? You want to improve. You don't want a cylindrical surface on your design. So one thing you can do is take it up to the next level by creating a G2 surface continuity at the tangent lines. Now, if once again, as I mentioned earlier, as you're driving down the road and you're going from the blue to the green, right, you're going to transition over, riding along an off ramp maybe, or transition ramp. Now, notice how this is constant, a constant radius. So if you're going 60 miles per hour, you were going fast, 100, then you slow down to 60 as you transition. This stays constant, like it's a constant radius. So imagine going 60 miles per hour constantly, or a constant radius of 60, let's say, or 50. And then you transition over to the next one, and then you can speed up again, right? Okay, so this constant radius or constant velocity is considered boring. So this is what you see on the corners of maybe a coffee table or or at your desk, either you see a sharp corner where you have G0, or you see a round fillet, constant radius, G1. So for stylists, that's considered ugly or boring. So we can improve on that. So that's what we're doing now. So we've created a cylinder. And one of the things that you do want to do is you want to at least go up to that tangent line of the fillet or go beyond it. So instead of having a tight turn, you can take this tangent line and move it further back and start transitioning from back here as you transition over to the green surface. Okay, so typically what you'll do is go further beyond, start off a little flat, and then you start rounding off. It's just a smoother transition. All right, so I'm going to take the cylinder. I'm going to increase the radius. Let's see. I'm going to increase it to 100, see where it lands. 100, preview. Okay, so I want to at least go to the tangent or further out. Let's keep making it larger. So I want to go beyond the tangency of the fillet. Okay, I'll just make it 125 radius and OK. Okay, so I don't want this boring, ugly fillet, so I'm just going to hide it. Right click, hide. Actually, let me bring it back just to show you that. See how we have the tangency of the fillet right here? So one thing we do want is we want from this edge, C0 or G0, we want to use the same distance from this center to this intersection as we want from this center to the intersection of the cylinder in the blue, right? So we want the same distance if possible. Makes it a cleaner transition. So it's not going to be near the tangency of the fillet. We're going to go further out, which is okay. Okay, so let me hide that fillet. Probably don't need it anymore because it's boring. Okay, so let's make a better looking transition. Okay, so what I'm going to do with this cylinder is I'm going to chop at these surfaces. So I'm going to take this blue surface. I'm going to split it with the cylinder. So let's go back to Essentials. I'm going to use Split. I'm going to split it with the cylinder. If it picks the wrong side, you can always flip it here. And OK. Now we're going to do the same thing with the green surface. We're going to also split it with the cylinder. Got the wrong side, so let me flip it. There it is. And OK. All right, so I'm done with the cylinder, so I can just go ahead and hide it. All right, so I want a smooth transition, right? So again, imagine you're a civil engineer, you're making a highway. Here's a new highway, here's an existing highway, and you want the traffic to transition smoothly over to the next highway without the need to have to come to a stop. Look both ways, make a right turn, right? You want a nice smooth transition to keep the traffic flowing. All right, so let me turn this to a blue surface. Right click Properties, make it blue. And I'll make this one green, just like the original one. Okay, so now we're going to connect them. Okay, this time we're going to use a different command. There's a bunch we can choose from. We can use fill command, we can use blend, we can use multi-section lofting. There's different ways to connect these two surfaces. I'm going to use blend. It's actually one of my favorite commands, blend. So I'm going to blend from the blue surface. So from the blue surface, I'm going to pick my first curve, which is the edge of the blue. My support can be a surface or it can be a plane. So I'll pick my surface. Now let's go to our second curve, the edge of the green surface, the top. Okay, so I got the top of the green, and my support will be the green surface itself. There it is. Okay, I want you to notice that these two white arrows are pointing in the same direction. Let's hit preview. Okay, so we got a nice clean surface. What happens if I flip one of these arrows? So if I click on one of them, notice it changes direction, and hit preview. It's going to give me an error message, say, okay, something's wrong. Hit OK, and it should give you a preview. Yep, so it's trying to twist because they're pointing in opposite directions. So as long as they're both pointing in the same direction, it's okay. Hit preview. All right. There's also another set of arrows. So if I was to click on this one, which is coming off normal to the edge, if I click it, hit preview, it's just going to flip the direction of the surface, the tangency. Okay, we don't want that, so let's flip it back. So now the arrow is pointing in the right direction, just like this one. And preview, that looks good. Okay, so it looks a lot cleaner. It doesn't look boring. It doesn't look ugly, right? It's a smoother transition. But we still have a problem. We still have tangency. So even though this is a cleaner surface, a cleaner transition as you go from one surface to the other surface, this middle surface now, even though it's curvature continuous, it's not boring, it's not a constant radius, at the transition areas, there's still a G0 and G1. So it's still point continuous and tangent continuous. Okay, and I can tell because here's the option, tangency. So it defaults to tangency. I can actually drop it down to G0, point continuity. Let's see what happens. So I'll drop the first one, the first edge, first continuity to 0. See what happens, preview. Notice we have a sharp G0, point continuity. This one is G1. It's still at tangency, the second continuity. This is the second one. Let's drop it down to point continuity. Hit preview. Now you notice we have G0, point continuity, right? So in some cases you may want this, in most cases you don't, right? So we don't want G0. Actually, we want G0, but we want to improve on it. Go to G1, tangency, both of them. Preview. So now we got tangency, and let's improve on it. Let's go up to curvature continuity. So this is G2, curvature continuity. Watch what happens when I hit preview. You're going to see the surface actually push outward in 3, 2, 1. Preview. See how it pushed outward? So the reason it pushed outward is because it flattened this more, so it's a smooth transition. So to feel the transition as you're driving along, right, or going on the roller coaster, in order to feel, so as to not to feel the transition as much, you flatten this out a little bit before you start curving inward, and then you flatten it out again almost as you go into the next surface. Okay, so let's drop it down to tangency G1. Hit preview again. Notice you'll feel this transition a lot more. So to feel the transition a lot less, we'll move up to G2, curvature continuity. And watch what happens when I hit preview. 3, 2, 1, preview. See, it almost flattens it out even more, or actually mimics more the original surfaces. So it's a smoother transition before it goes into a tight curve. Now, some of you are probably saying, hey, teacher, I don't have, or sorry, Catia mentor, I don't have the curvature option. Okay, so a good example at work, at my job, when I'm using Catia, whether it's Catia V5 or Catia 3D Experience, I also don't have the curvature option. So that's because we have the basic license of generative shape design or the generative wireframe and surface. So most designers that create surfaces don't need to use the curvature continuity option. So if you do need the curvature continuity option because you're creating Class A surfacing, right, for automotive, interiors, exterior surfaces, then you would have to go in and pick a license that has the more advanced options like curvature continuity. All right. So trim is the same as this command, trim. So it's actually including the trim options in here. So what is trim? So trim is actually two commands in one. It's actually join and split in one, called trim. So what trim does, it'll split a surface, remove the excess, and then join the leftover surfaces. Okay, so that's trim. Actually, here there is no excess because we trimmed it off already with the cylinder. Let me hit OK. If we were to go back to fillet, so here's fillet. Let me turn off the blend for a minute. Okay, so when we did the fillet, double click, it removed what's shown in this vanilla color. It removed the excess because the trim options were on. So we removed the excess from the green and the blue surface and then joined them all into one surface. If you were to turn off these options, trim, it would remove, actually, it would keep the excess and keep all three surfaces, the blue, the green, and the fillet, as separate surfaces. Hit OK. So notice if you uncheck the trim option, yeah, it'll create the fillet, but it'll keep the excess, as you can see, on the blue and the green surface, and keep the surfaces as three separate surfaces. But in most cases, when you use fillet, you want to have trim option on to remove the excess and to join all three surfaces. Okay. Now, again, we're getting away from this fillet because it's boring, right? We prefer our blend that we just created, our blend, right? Okay, so let's go ahead and hide that fillet. I don't think we're going to use it again. Okay, so here we have a nice smooth transition from the blue to the green with our new gray blend surface. Okay, so let's go back to blend and I want to show you something. Here we have the tension tab. So tension. If you ever flown a kite, so maybe when you were a kid, went to the park where you flew a kite and you have the string and the kite is way up there in the sky, and you can see that the string has curvature to it due to gravity, right? So even though it's lightweight, it's still pulling on it. Gravity is still pulling on it. And tension, imagine you pull on the string, or maybe you pull forward to give it some slack. It's the same idea here. We can increase the tension. Okay, so here's the first one. Here's our second one. Okay, so if I go to the first one, our T1, T1 is on this side, and T2 is on the opposite, or vice versa. So that's why there's T1, keeping it constant. You can actually have a variable. We'll just keep it constant throughout. So this is T1, T2 for our first tension, and this will be the second tension. So we'll just leave it constant. If you don't want to leave it constant, you can always go linear and use a different tension on the first point than the second one, and it's a variable and it smooths out as you go across. I'll just keep it a constant. Okay, so I'm going to increase the tension. I'm going to exaggerate and go to 3, from 1 to 3.3. and hit preview, see what happens. 3, 2, 1. See how it pushes it out? Okay, so that's tension. Let's see if I increase the second tension down here, the second tension. Increase it. Preview. And it really pushes it out. So it's forcing to follow the curvature of the green surface here by increasing the tension. Same thing on the first tension. It's forcing it to follow the curvature of the blue surface by increasing the tension. Typically on the tension, you want to stay between maybe 0.8 and maybe 1.4. That's a good range to be in. You can go beyond that if you need to, but typically you try and stay in that range of 0.8 up to 1.4. I'll just leave it at 1. And preview, and there it is. All right. Let's go back to Basic tab. And I'm going to click the trim option, even though there's no excess to trim off. By picking this option, it's going to join all 3 patches as one surface. And OK. So it joins it all as one. If I go back and remove that trim option and hit OK, it keeps it as 3 separate surfaces. Let's go back and turn on the trim option. So now it'll join them as one. Okay, so trim removes excess if there is any, and then joins all 3 surfaces. Okay, so let me change the color on this. Right click properties, and let's see, let's give it a dark green color. Actually, let me give it a different color so we don't get our colors mixed up with the existing colors we're using. I'm going to use maybe a purple color. Okay, so there we have our purple surface. Okay, so there's actually a higher level of curvature continuity, which we didn't have an option to that. So let's go ahead and explain that. Okay, so we just reached C2, or in our case G2 because it's a surface, curvature continuity. So at our transitions, which there's 2 transitions for us, we have a connection, G0, a tangency, G1, and the radii are equal, so that's G2. Okay, so we have a connection, we have tangency, and the radius, let's say the radius is 50 equals a radius as you enter the next surface, which is also 50. So the radii are equal, or you can say the velocity is equal if you're going 50 miles per hour as you exit and enter the next surface or curve. It's also 50. They're equal. Okay, how can we improve on that? Okay, so to even improve further, you can go to C3. Okay, so C3, and you'll see C3 in a different module in Catia, and we'll talk about it in a few minutes. Okay, so C3. So it's still called curvature continuity, like C2, but this is C3 curvature continuity. So now, on top of being C0, point continuity, C1, tangent continuity, C2, radii, or velocities are equal. Now the rate of change are equal. So what does that mean? So the rate at what the radius is changing as it's going from, let's say, 100 radius, 90, 80, 70, 60, let's say 50, also equals the rate on the green surface. As you enter the green surface, the rate of which the radius is changing is also equal to the rate as it exits the blue surface. In other words, if we're talking about velocity, so if you're driving at 100 miles per hour and you slow down, let go of the gas pedal, and now you slow down to, let's say, 50 miles per hour on the blue surface. As you exit the blue surface at 50 miles per hour, you're going 54, 53, 52, 51, 50 as you exit. And as you enter the green surface, you go 50 and then 49, 48. So think of acceleration or deceleration. So not only are the velocities equal, let's say 50 miles per hour as you exit, 50 as you enter, but the deceleration is equal also. So if you're decelerating at 1 mile per hour, I know it's a small number, but if you're decelerating at 1 or 10 miles per hour, let's say 10 miles per hour decelerating, it's also 10 miles deceleration as you enter the next surface. All right, so that's C3. Unfortunately, we don't have C3 in the surfacing workbench, but we do have it in another module, but we're not going to model this. All right, so now let's do an analysis. Okay, let's say we're done. We're happy with our surfaces. We're not going to model a G3 curvature continuity because I'm limited to what I have as far as the commands. All right, so let me go ahead and hide the blue curve, and I'm going to hide the green curve. Okay, now I'm going to intersect the surface with our plane. So I'm going to use the intersect command. Intersect surface with our plane. So that'll give me an intersection. Okay. Okay, so we intersected right down the middle of the surface. All right, I'm going to give it a color. Right-click Properties. Let's see, a color I haven't used yet. Actually, don't want to use this color because we're going to use it a few minutes. I'll just go with the brown color and give it a thickness. Okay, so there's our intersection. Okay, so now we're going to analyze our surface and our curves. Okay, so first I want to talk about Porcupine curvature analysis. Okay, so we're going to go over to the Review tab. We're going to go to Review. In the Review tab, we're going to go to Connect Checker Analysis. I'll cover this in a separate video. The one we want to use is Porcupine curvature analysis. Okay, I'm going to click on it. And I'm going to pick my brown curve. And there's your Porcupine analysis. Let's look straight into it. Let me go to View tab and look straight into the front view. There it is. Okay, so this is what we want. We want our Porcupine curvature. As you can see, there's changes to the Porcupine. Here we're turning right, and as we tighten the curve, right, we got to slow down. The centrifugal force is pulling us outwards. We're turning right. So you can see the Porcupines increase in size as the curvature tightens. And as it starts to flatten out, the Porcupine curves get smaller. So here we're turning right, and then there's an inflection point here where we start turning left. So we're turning left. That's why the Porcupine flipped at the inflection point. So here we're turning left, pulling on the steering wheel, going left, or rotating the steering wheel, going left. And here's another inflection point. So now we straighten out and start turning right. And that's why the Porcupines flip again. Okay, so this is what we want to see. We want to see nice, smooth transitions. I mean, this is not very clean. This area we want to clean up. And you can tell this is where we have our transition from our blend to the green surface, right? We can see it right there. I'm actually going to turn on fillets or show edges. So I'm going to go to view modes, and I want to show all the patches or transitions. I'm going to go to this one, and there it is. So we can see the transitions. Close it. Okay, so you can actually see, you can tell where there's a transition change on the Porcupine. It almost looks like a little disruption. It's not as clean as the rest of the curve. Let me go into front view. It's not as clean. Same thing on this one. And that's where our seam lines are at, right? That's where we have our transitions. So again, we can improve on this if we have the option to go up to a G3, which in this case we don't. But it's still good enough. It's still clean enough. All right, so I'm going to go back to blend. I'm going to go back to the blend, right, that created this surface. So I'm going to go to blend. I'm going to keep that curvature. Let's look at it from the front view. All right, so I'm going to go back to blend. Double click on it. And I'm going to change my curvature down to G0, point continuity, on both of them. Okay, so we're dropping from G2 down to G0. And hit preview. Notice what happens to our Porcupine. Okay, so our Porcupine doesn't like it, right? So our Porcupine, all of a sudden, there's a drop. It's not a smooth, clean transition on the green line that we see here, right? All of a sudden, it just stops. Then it continues on over here on this side, right? Okay, so let's improve on it. Let's go up to G1, tangency. G1, tangency. And preview. That's a lot better. But notice what happens to the Porcupine at the transition locations, right? Here the Porcupine, all of a sudden there's a step down. Okay, there's a drop, there's a step. Same thing on this one. All of a sudden there's a step, sudden drop. Okay, so you can tell by the Porcupine when you don't have a nice curvature continuous transition. So we should be able to tell by the Porcupine curvature analysis that we've dropped down to tangency G1. Let's go ahead and improve it to a G2, curvature continuity, G2. And preview. That's better, right? And OK. So once again, at our transition areas, we have G2, G2. But the rest of the Porcupine should be at least a G3. Okay, so along the original blue surface, there's no interruptions. There's no sudden breaks or bends on the surfaces or sharp edges, right? So here on the Porcupine, we have at least G3. We have G3. Then it drops down to a G2, which is okay, good enough for us. And it goes back up to a G3. And at our transition, drops down to a G2. At the transition, drops down to G2, but then it continues on with at least a G3 curvature continuity. All right, so that's the Porcupine analysis. Now let's take a look at light reflections. Okay, so to look at better reflections off of the surface, I'm going to go to a different app or workbench. I'm going to go into the freestyle. So those of you that are going to be doing surfacing, if you work in aerospace, you're mostly going to be using generative shape design when you're designing wings or fuselage or the empennage section of an aircraft, or working on the interiors of an aircraft. Those of you that end up working in automotive, you're going to be using both generative wireframe and surfacing, or generative shape design if you're using Catia V5, and freestyle. So you're going to be using a little bit of both. Freestyle, you're basically shaping your almost like making creating pottery out of clay. You're just freestyling. You're just pulling on the surfaces using nodes. Where in generative shape design, you're mostly defining your surfaces and curves by mathematically by using points, by using tension, etc. So mathematically, you can create curves. Those of you that work in want to be aerodynamicist, for example, in an aircraft, you can even use conic equations and generative shape design or generative wireframe and surface to generate your surfaces. If you're just freestyling mathematically, you ignore math, right? Pretty much, and you're just sculpting, just like creating pottery using clay. All right, so and there's also something in between called ISOM, and I'll cover that in a separate video. ISOM is something in between these two options. All right, so let's go into freestyle. Okay, so freestyle, so we're in the freestyle shape design workbench. And we have more options when it comes to analysis. Okay, so first let's go back to lighting, which is available in all apps. So I'm going to go to the View tab. So in any app, you should be able to change the lighting. So I'm going to go back to ambience and camera. I'm going to override the lighting. Okay, so we have lighting. See, I can change the direction of the light, as you can see. Okay, and I'm going to go into neon lights. And I'm not getting a good reflection. Let me see if I change the direction of the lighting. Okay, you do get a little bit of reflection, not as much as I want. Okay, you get a little bit of reflection. Okay, so see the lights or the neon lights reflecting off the surface. So in automotive, this is very important. It's also important in aerospace, but it's a lot more important when you're creating Class A surfacing in automotive. You want to analyze your surfaces and your curves using the Porcupine analysis, as we did earlier. And now we're going to look at the way lights reflect off of a surface. Okay, so let me close lighting. So in the Freestyle Shape Design app, we have more options. So let's go back to Creation. My mistake, Analysis. And we have more options when it comes to analyzing. We even still have the Porcupine and the Connect Checker, which I'll demonstrate in a different video. We also have reflection lines, for example. We also have inflection lines. We have isophotes mapping. I'm in the wrong view mode. That's okay. Let me go ahead and change that. So let's go to view. I think I'm supposed to show with material. Oh, wrong one. View modes. There it is. Okay, so shading with materials. And now we get a better light reflection. So when you're working for a studio department, whether it's working on exteriors, where you're working on the windshield, the rooftop, the doors, the bumpers of the car, or the interior, whether it's the seats, the dash, center console, typically what they'll do is they'll bring in all the designers, including the supervisors and the decision makers, to come in, and you all sit in as a group, and they'll use an overhead projector and project it onto a large, typically a white wall, and everybody takes a look at the car. So if you're looking at a car, you want to see the way the lights reflect off of the surface. And if the decision makers on top like it, they'll give you the thumbs up. If not, they'll tell you, you know what, we need to improve this corner on the car, or even the surface on the headrest, for example. So they'll give input, and then you have to go back and fix it. And I do have to say, if you work in a studio department, there's a lot of hours spent on perfecting the surface. Maybe something that'll take you a week to work on in aerospace may take you a month to do the same thing in automotive because they want that nice clean surface. Okay. All right. So if I show you examples online. Okay. So as I mentioned earlier, if you work for a studio department, once you've created the exterior surfaces in Alias or Catia or another software, you can turn on the options, right? As I showed earlier, how to turn on zebra stripes or lighting to reflect off of the surface. And they can tell the decision makers, the supervisors, managers, they can tell if you have a nice clean surface by the way the zebra stripes flow. They want to see nice flows. It's okay if it zigzags as long as the stripes don't break from each other. They don't disconnect or there's a break. So if you ever been to a car show, or maybe you see it on online or on TV, where they'll take a car, a new concept car, the next model year that's coming out, and they drive it through a tunnel of lights, right? So this is where stylists, or maybe even the competition, or the decision makers in your company get to take a look at your product, and they want to see how the lights reflect off of the surface. They want nice, clean reflections. So if you ever find yourself stuck on the road, there's a lot of traffic, or you're driving through a tunnel with lights, you're going to start looking at the way lights reflect off of the surfaces of the car. You want to see nice, clean reflections. So here we have a nice, clean reflections, right? As you transition from the hood over to the fender, for example. An area where you don't have a good, clean reflection is in this line here. Notice how the zebra stripe is going up, and then it breaks, and then it continues over here to the left, and then goes upward. So here, by looking at this break, we can tell that we don't have G3 or G2 or G1 continuity. Here, this is G1. So this is a sharp edge, and in this case, obviously, is intentional. You can also see it on the left side, a lot clearer. The reflection lines all of a sudden disappear as you transition from this surface and go upward towards the headlight. Okay, so obviously this is intentional, so we have a sharp edge. We have G0, point continuity. We don't have tangency, we don't have curvature as you transition from one surface to another. Okay, so here's something I found online. I'm not going to take credit for this. Okay, so here we're looking at the rooftop of a car. Here's a windshield. Okay, so typically when you go work for a studio department in automotive, first thing they'll do is they'll train you on how to create a rooftop surface, how to create from scratch a windshield surface, and then how to analyze it, right? Using curvature, porcupine curvature analysis, and also using the zebra stripes to reflect off of. All right, so here's a good example of G0, right? Just like we were looking at the front end of the car, the previous picture. So the reflection lines, the zebra stripes, here we have the white stripe, all of a sudden breaks, and then it continues onto the windshield. So here we have G0. Okay, so this is a sharp edge as you transition from the rooftop surface to the windshield. Okay, so we have G0 continuity. If you want to improve on it, we can add tangency, G1. Okay, so we have tangent continuity, G1. So it's a little better. The zebra stripes kind of bend. It bends as it goes into the windshield surface. So at least maybe that's what you want. So at least here we have G0 and G1 continuity. So point and tangent continuity. But in most cases we want at least G2. Okay, so G2, notice how the stripe continues on from the rooftop to the windshield. So we can tell by the reflections that we have at least G2 curvature continuity. So G2 curvature continuity as well as G1 tangent continuity and G0 point continuity. Okay, so let's go back. Okay, just to recap, again, C0 point continuity, there's no gaps between the two curves or two surfaces. C1 tangent continuity. C2, we've accomplished curvature continuity, so the radius as you exit equals the radius as you enter the next curve or surface. In C3, the rates are equal, so the rate of change on the radius or the rate of change in velocity, which is the acceleration, are equal as you exit one curve or surface and enter the next curve or surface. And one last thing I want to leave you with real quick. I'm going to go back to that cylinder. Okay, I'm going to take that cylinder and I'm going to cut it with the plane. I'm going to go back to generative wire frame and surfaces, so I can use the split command. Okay, so I'm going to split the cylinder with one of the planes. I'll split it with, let's do it with the vertical one. Now I want to flip it to the other side. Okay, so we're going to keep the left side of the cylinder. And okay. Alright, so let me change the lighting. It's too bright. So let me go back and change the lighting. Oh, go to default. Okay, that's better. Okay, so I'm going to extend this surface. Okay, I'm going to use what's called extrapolate. Let's go back to essentials. So you're going to use extrapolate quite a bit to extend a surface. You can also extend a curve. Okay, so I'm going to extrapolate. The top of the surface. So extrapolate this top edge of the surface. Okay, so I'm going to extrapolate. I'm going to extend it. Notice how it almost flattens out. Okay, so it's creating a tangent surface. Notice the setting is at tangent. Okay, so as I extend the cylinder with tangent continuity. So as I extend it with tangent continuity, it just flattens out. Watch what happens when I go to curvature continuity. Curvature. It follows the curvature of the cylinder, right? So it's extending the surface. And let's keep going. And it's almost basically going back to its shape, right? Obviously, it's only going in one direction. That's why I think there's a limit because we're extending it in this direction. So, curvature continuity, the radius are equal. That's why it's going back to its shape. So if I was able to keep going, it'll close it back to a complete cylinder. Okay? If I drop it down to tangent continuity, the radii are no longer equal, or the velocity are no longer equal, so that's why it gives us a flattened out surface. Okay, And you're going to see this throughout other commands in Catia or alias, the tangent option or curvature option. Alright, so that's the end of this video. Hope you liked it, and I'll see you in the next one.